I am still catching up on the notes of yesterday. I have some really, I have some good news with Google. So Mary's Honda problem that you had with Snippy yesterday, I found. So if we went to, okay. So firstly, I think I'm going to. Okay, so I must just leave this. This is something else. Hey, where's my mouse? If you go to the GitHub for Bactopia, then you see here there's issues, right? And what's really interesting was that if you look through the issues, then where did it go? Workflow Snippy failed, okay? And if you look at this error message, this was, so what happened here was that with Mary's, the institutional high performance computing, the singularity wasn't working. So we thought to try using the Conda environment and we got an error, okay? So if you look at the error message, then down here, the error message, I think this is the same error that it was. Yeah? No tablets, yes? Okay, so this is from a Conda environment called Bactopia variants, okay? Then they listed, and somebody else got the same error, and they solved it by installing the VCF lib on their operating system. But you can't do that because you don't control the HPC, okay? Other people commented, and there's Robert the T coming in, can we try with Docker or Singularity? And then he's giving some other issues. But, I had some good luck because I then looked on the Bioconda. The Bioconda thing is what I figured out is that the problem is with a piece of software called VCF libs. Okay? And if we look at the issues here on Bioconda and you ask about the VCF lib, then somebody else is trying to run a different tool that uses VCF lib, and look at the error, same error, okay? So then I was like, what's going on here, okay? So, turns out that the issue is that if you look at the Bioconda recipe for VCF lib, so firstly, let's look at the Bactopia variants Bioconda recipe, okay? Which is very similar to the Snippy Bioconda recipe. So if we go here, this is the recipe. Then you see that it says VCF lib greater than 1, less than 1, less than equal to 1.02, okay? So 1.02 is the latest that it will accept, okay? So now if we go look at what does VCF lib do in its recipe, depends on this, tabex pp, okay? If you look at which tabex pp packages are out there, okay, with let's hope that this doesn't crash my computer. Let me just go to the problem is that the library, as we found, and we tried to debug this thing yesterday, the library that is there is .1 version of the library, and we want the .0 version of the library, okay? And so, is this going to crash my computer? And you see that there's actually only two versions of the library available, 1.10 and 1.12, okay? Turns out that the 1.10 comes with a .0 version of the library. So if you can convince the thing to use the 1.10 version of the library, everything starts working. So the last piece of the puzzle that I don't have a solution for, and I've asked Robert Petit or however you say his name in American, to help me solve, is how do you tell Bactopia which Conda things you want to do? But what it's clear is that, and then somebody else reported that Snippy, just standalone Snippy doesn't work. Okay, so from Conda, I mean. So all of this means that a solution is very close. We know where to solve it, and then we can make this thing work. There are other issues, but anyway, bottom line behind all of this is that Robert said that he was very happy that that I was using his tool for training. And he said that definitely people should be in touch, about like if they have issues like this, right? And I have some other issues, other bugs and enhancements that I've seen during this course, right? He is on the microbitfy Slack, and you can open issues here. But I think that to be polite, it would be better that we, like if somebody has a problem with Bactopia, that we first mention it within our community. Maybe somebody else has a solution before we escalate to Robert and say like, look, there's this and this bug. And I mean, I think this would be great how if we can collectively build up knowledge on this bioinformatics software. And as I said, like this thing of WhatsApp groups, they never die. They just like become zombies that go like they're dormant for a long time. And I mean, like yesterday, one of Osvaldo's colleagues, who was on a previous training, forget his name, Nuru or something like that, popped up with a question about poliovirus sequencing on one of the WhatsApp groups from 2 years ago or something like that. Trying to remember who it was. Nuro Abilio, from your lab, was asking about poliovirus sequencing, Now he seems to have left the WhatsApp group for whatever reason. But this was from the WhatsApp group it was from June last year, okay. But staying in touch is very useful because then various other people, had some ideas, and I happen to know the people doing poliovirus work at NICD, and we can make these connections. Okay. Anyway, so that's about like bugs and things like that. I wanted to show you a couple of things, and then get into discussing those papers that I mentioned on the WhatsApp. Okay. So the first things that I want to mention. So I want to actually have a bit of a nanopore focus today, right? We've been working with Illumina, but as I've been saying in our discussions, I don't feel that nanopore tools, they're like 100%, they're not as polished as what we see with the Illumina tools, but they have great potential, okay? So, I happen to, when looking for some nanopore data, discover some nanopore Vibrio cholera data from Cameroon, okay? And I think I'm going to move the laptop around so that I can see the screen while working. And this is the Haiti data that we were looking at, okay? And this is what happens if you do a de novo assembly of that data, okay? I'm just switching over to the Haiti history. I'm waiting, so Galaxy I've started a whole lot of jobs on Galaxy. So some of mine are waiting to run. So I did an assembly and I'm waiting for some LST typing results on this data. But while we wait for that, if I look at the nanopore data from Cameroon, I'm still doing various processing. But if I look at the, where did I put it? The bandage if I look at the bandage images, most of these are finished computing. And most of them look like this, okay? So what we've got here, in this case, 2 perfect circular chromosomes. I mean, it looks quite amazing to me as an assembly, okay? In other cases, our story is not as pretty, like this, okay? So this sample number 842, it's got 2 chromosomes over there, but it has something else going on as well. This overlap is probably a repeat in the genome. We seem to have 2 organisms in one, at least, going on here, not counting all the other little pieces over there. So that's 842. And so all I did here, okay, I loaded the data into Galaxy. I used filter long to filter by quality and read length. I used unicycler to do an assembly, but I didn't have any Illumina to polish with. I just did a basic assembly with unicycler, which behind the scenes I think is using Fly, but whatever it is, I did an assembly with unicycler. And then I ran, from the assembly graph information that comes out of unicycler, I ran it into a bandage to visualize what the assembly looks like. And then when I saw this, then I decided to use Kraken to see what's going on. So remember that number 842. Let's look at the Kraken report for 842. And we see that 53% of the sequences align with something called Morganella morgani. Okay, so I don't know if you. Oopsie, wrong button. If I zoom, then it's kind of hard to see the screen. And then there's some other things, but they're in much smaller proportion. Let me just see. Just want to zoom out and see if I can spot any Vibrio here at all. So there is a Vibrio cholerae in the sample, 4.5% of Vibrio cholerae in the sample, okay? Which probably explains the strange genome assembly that we saw, the assembly of 2 what looked like Vibrio cholerae genomes, and then another weird twisty thing, okay? And this kind of, I think you saw this the other day when you're doing Galaxy, that you can use Kraken for reports like this. I also ran a multi-QC on the data, which has got, again, the characteristic sign of contamination by the change in the GC content of the sample, you know. So we're expecting 47%. Some are actually low. I don't know what could be in those samples. I haven't looked yet. But yeah, so the assembly looks great, okay? But if I download one of these assemblies, one of these assembled genomes from here, okay, so if I take the, let me go choose one where the bandage looks great. So if we take, for instance, 852, okay, bandage image is looking great. If we run this thing into Kraken, we find out that this is all Vibrio cholerae. So let's go find the 852 assembly, final assembly that's here. There's 852, 852, and I'm going to download this. And it's two sequences because obviously there's two contexts, two chromosomes, okay? And I'm going to load this into pathogen watch. Upload. Where's the, there's meant to be a plus thing on the screen. So, oh yeah, let's go here first. There, plus. Wait for it to upload. So the problem with nanopore is the homopolymers, which lead to false insertions and deletions. Okay. Apparently we've had some network problem affecting the whole country since yesterday, so that could explain the slow network. Okay. Let's say, why is it uploading a second time? Okay, so now it's going to start giving us results. So what I'm interested in here particularly is the gene by gene analysis of what the gene content of this assembly is. Okay, so if you do the gene by gene analysis of the Illumina assemblies, which I don't have an Illumina assembly on hand right now, then you see that you find alleles that match known alleles from Vibrio cholerae. Okay, even though assembly on your assembly graph is scattered in lots of different ways, you do find that within that assembly, the genes are being assembled correctly. Okay. So, and this, by the way, Moss is going to find out from his colleagues what the details are, but I'm almost certain that we're dealing with R9.4 sequence here. Okay, this is not R10 flow cells, which have only come out recently. So I'm just waiting for the MLST to finish computing. Well, the first MLST is already done, so I can start looking already, okay? And what we see here is that the 7-gene MLST typing of this chromosome already has problems. It's managed to get a matching allele for the ADK and the MET-E genes, but it's not finding matching alleles for the other genes. Okay, and therefore it's not able to assign a sequence type. It's able to do some AMR prediction, but again, when we look at the virulence genes, some things found, some things not found. So if we look at, so this is a L2 cholera, right? And we know one of the defining features of O1 cholera is that it has CTXA and CTXB genes. They're missing. If we look at the TCP cluster of genes, mostly missing, you know. So pure nanopore assembly with this generation of nanopore, which is an older generation, is not giving us the resolution that we need for genomic epidemiology yet. Okay, it's letting us do some typing, but not the details. Okay, so what's the solution? Okay. So this was sample. This was 852, right? I've done some darker polishing. How far is my darker going? Sorry, wrong data set. Try this. Yes.
I'm thinking, isn't maybe the part of the problem starting with us from where you
starting with people from Panga?
contamination?
No. Yes. We definitely saw examples of combination in the Morganella sample, right?
That contamination, I think, may not be due to the analysis.
No, but that's happening upstream. So what is Morganella, right?
Yeah.
So Morganella is a commensal bacteria found in the human gut. Okay. So and I should do more of what George recommended, the touring of the labs. But my understanding is that the cholera is sequenced from culture or from pure stool isolate. Is it culture, right?
Yes.
Which means that you.
It's culture, yes.
So then from the culture they're going to pick a colony, right?
Yes. And that's where the contamination comes from, depending on how the colony is picked. Some people pick the colony and they would prefer the media and then they have like.
And is it a selective media that they are?
Yeah, they have selective media. Then later on this week, but obviously in that process, if aseptic, conditions or techniques are not applied, then you have.
So I think it's a few things, right? So the one thing that we're seeing is, and I mean, I had a discussion in Lusaka with Solo where they were having some troubles with Corynebacteria diphtheria, which the culturing is quite challenging. Okay, so you've got too few reads. Okay, then the picking the colonies in some of the Malawi data that Tracy used for her galaxy teaching, the wrong colonies were picked or something like that. But because what looked like, if I looked at like what were the characteristics of the contaminants there, okay? It was Morganella, and I forget the other one, but it was another bacterium that can cause watery diarrhea. So in other words, this could be clinically similar to cholera, but it's not cholera, right?
It's like
Yeah, okay. And but all of the contaminants in that case were gram-negative rods. So they appear similar to cholera, which is a gram-negative comma, basically, right? When examined under a microscope. So microscopy maybe wasn't distinguishing between, what was going on there. Or perhaps also the I don't know what biochemical, because I know that when you're growing your cholera, the medium is meant to give the colony a particular morphology and color and all of those things. So something was going wrong there. But that's separate from the, because the thing is that, like, when you say acidic environment, this sample is coming from a clinical sample where it is a mixture of different things, right?
What I mean is so when we take out the clinical sample, we grow it. At the point when we grow it, the method is actually supposed to apply in terms of your techniques, you must really make sure if it's a single colony,
Yeah.
touch a single colony.
Yes, exactly.
Not
Touch the whole.
but also the selection of the colonies, because sometimes again the colors, say yellow colonies, dry.
It's challenging, right?
It's challenging, of course. But then also the loops you are using now to proceed for extraction. Because at the point where you select your pure colony, we assume everything is fine. And when you move over to extraction, again, there is a whole different process.
And of course, then you've got between sample contamination. And I saw a lot of that with SARS-CoV-2.
And also environmental contamination from tubes, because those are not, unless you are really strict that all the
that must be stored always in a
free
yeah.
And all that kind of, so
Yeah.
I think the challenge will be from there. So
but besides that, where I think that what might have happened there was a mistake with quality picking. The other things that I've seen, as I said, if you're getting 30% human reads in your Mycobacterium tuberculosis sample, that is definitely somebody's not following lab technique correctly, because you're meant to be gloved up, you're meant to not have any human reads in your environment, right? That's just not meant to be happening, okay? Let alone if you're getting a fecal bacteria contaminating your Mycobacterium tuberculosis. They're like, no, hang on, guys, this is just, the lab people need some serious workshops on technique, okay?
But would it be helpful then to do kind of map to the reference? So I select a certain percentage of mapped reads and I set that as my minimum that I check with.
Yes and no. So I'm very familiar with this problem in the world of Mycobacterium tuberculosis, because if you have something that maps, because the question is, what is the mappability of your contaminant, right? So if your contaminant that will not map, then you're safe. But the problem is that sometimes, especially with short reads, you can get something that is mapping, but it's not from what you actually think it is. And there is some work from Gallo Goig and others in Inaki Thomas's lab, where they show that you can get false variant calls if you are not pre-filtering, okay? So in the world of Mycobacterium tuberculosis, where it's a very limited, I mean, there's now a preprint out from Connor Meehan's group on the pan genome of Mycobacterium tuberculosis, and the conclusion is the pan genome is very limited, okay? This is a clonal organization. Then there's various techniques have been developed for filtering out contaminants. And then you can throw away your contaminants and carry on with your non-contaminants, and then you're fine. But I don't have knowledge of whether you can just map and discard the rest and assume that everything that you map is actually from the sample correctly. Probably, but we need what we need is some master students to make some simulated read sets where you mix in different proportions of different organisms in a simulated Illumina reads, run it, see what, we need more research, to find out which kind of problems are actually causing problems and which ones are just us being paranoid, okay?
Peter, is there also an assumption that it's from contaminant?
Well, in the case of that other sample with Morganella, 53% was Morganella and 4.5% was Vibrio cholerae, right? So would you continue with downstream processing? What's your depth of coverage going to be like? When, you've, because however many, let's say there's 1 million reads there, but you've thrown away 95% of those 1 million reads because they're not Vibrio cholerae, So, which threshold should we set? If it's contaminated at 10%, 20%, 30%, where should we draw the line? Maybe it's somewhere there in the literature and I haven't found it, but I don't know where. I don't have a number to say. So I think like I do think that the mapping approach. So if we look at those Malawi samples that Tracy used, okay, the end result was that the ones that were contaminated were discarded from later analysis because the mapping was way low. Okay.
I wanted to show the
Put it on the WhatsApp and then we can take from there.
The first link, you can open it there.
But in these things, then the next question becomes, okay, fine, maybe somebody in Brazil has figured out like the magical answer to this, okay? How are we sharing the best practices?
So
Okay.
I'll share with you I put on the group the QC report on the mapping. If you get that,
I'm just looking for my mouse, which is somewhere here. So my WhatsApp's not open at the moment to try and reduce the distractions while doing this. What? Now it says it doesn't recognize me. Hang on 1 second while I try and convince my computer that to actually know who I am. No, not that. Okay, this one. So I have a QC report on Panga. Let me download it and display it. Close this. Okay.
So for example, we have those percentages for the marked rates.
That's interesting. Yeah, so here 57%, 97%,
Yeah.
74%.
That's cholera. So what I was saying is this was the marked rate. So are we saying that, for example, if I pick those with 97% of the reads that are mapped to my reference,
Then I'm feeling solid here because also, by the way, it's interesting that it's always 97.1. Wonder what. No, but don't you think it's unusual that you see so many 97.1s? What is happening in the 2.9% of those reads? I'm wondering what they are. But okay, but there's a lot of commonality. But so let's say we choose 97%. That looks like we call that good, right? And then maybe this number. We choose a number here, and we say that maybe 6.5 million. Okay, maybe 6 million. Maybe we say 6 million, 5 million, 5.5 million, but we choose a number. And we say that we want at least 5 million mapped reads, right? This is for MySeq, NextSeq, what are you dealing with here?
this is NextSeq.
NextSeq, okay, but like for this platform, for this organism, we come up with some metric, right?
Yes. And then we now go downwards and see if we'll be able to get any.
There's 0. Okay, but there's no reads. That's a fail. Okay, but this one there was nothing to start off with, right? Sequencing experiment failed, right? There's no reads to start off with. There's 518 reads. Okay, negative control. Good. And in fact, that's good that you're getting nothing in your negative control, right? Well, are you having 2 negative controls, Panga?
It's actually 3. 4.
It's 4. Okay. But then, yeah, so then you choose like somewhere, some cutoff, okay?
So you see, Peter, so my question was, if I go for, let's say, the 97, and I pick those and then work with those reads, 97% upwards, will I be able to be worried that I might get
So we're always playing, there's always going to be like a line, false positives, false negatives, right? Because if you're throwing away the 75% over here, right? That's money that you're throwing away, right? So can you afford to do that? You know,
So at which place?
has the copper belt become the gold belt?
So how can I determine?
This is a not, so that there's two answers to your question. The one is, what does the literature say? Okay. And the answer to that one, I'm almost certain that if you guarantee and you try and find an answer from the literature, you won't find an answer. Okay. If you're lucky, you will find an answer in the literature, okay, in the scientific literature. Most of the time, we are not so lucky. Okay. So the next question is, what does the community say? Okay. And then when we say community, what does that mean? What is the community? Okay. So that's why I was talking about like Phage, other networks that we might construct, even that Slack group that we're on. Can we come up with something? Because during the SARS-CoV-2 pandemic, for SARS-CoV-2, that we were able to draw on some metrics from Public Health England that came up with like minimum depth should be this, you know, and various other. There's a document that Phage put out on QC metrics for SARS-CoV-2, right? That's from the Pipelines and Visualizations Working Group, right? And now there's all these different subgroups of the Pipelines and Visualizations Working Group working on best practices for HIV, best practices. Nobody working on best practices for cholera yet, but that can be started, right? So the two tools are the literature and the community, right? And I think the two things work together. And I mean, we absolutely need to build this because I don't have an answer for this.
But Peter, could you, if you, let's say you don't have a community, I'm just thinking about how I'm drinking water. Could you go to the next step, like in terms of, like you take some of those, you do like a variant calling analysis, you check the variants and you see, okay, I need a certain amount of support for variants. If there's strong evidence, like let's say most of the tests are giving that variant, then you can actually go a little lower in terms of how many you need. You know what I'm saying? But if it's like 60%, then you're like, okay, well, I could chuck away and I can take cool.
So there's your allelic fraction, you know.
Yeah.
But but you're bringing in the third thing. So we've got three tools: literature, community, experiment, right? So do you have a staff member or a student or something who can do an experiment? Because most of the time, like you know, when you're getting the variant callers, like you get your VCF output, like you know what you'd then be saying, Tracy, is write a variant filter that looks at like the depth and the allele percentage, and then filters that way. And you might get to do with that with SNP or something like that, right? You know, it looks at various like metrics or maybe, but what I'm saying is that it sounds like to do this, you're probably gonna have to build a tool because it might not be off the. No, but you can't view it by eye. That's not scalable.
If you don't have anything else, if you're not a scientist, and you wanted to like.
No, but look, I've heard of that. Helena in the Netherlands was telling me about their clinicians insist on eyeballing variants in IGV, and then doing variant calls by eyeballing the variants. That doesn't scale. How many examples you've got here? No, but what I'm saying is that you probably are, even if it means you're just writing a small script, you're building a tool. You're adding to the existing pipelines. You're not taking it as it is. So what I'm saying is that you're talking about the third technique, which is to do research and tool building and whatever it is. Even if it is small tool building, but it's still tool building, right?
So would there be value in setting a selection based on this? I decide the percentage. Let's say I map like this, and I go into my map trees. Let's say I set it at 80%. So from this, anything that's 80% maps to my reference, I'll pick it. And then I go to the map trees directory, and then do de novo assembly of those reads now, then maybe go to Kraken and see.
You mean the unmapped reads or the mapped reads?
The mapped reads.
But if they're mapped, then you know that they match the reference. So why are you doing de novo?
But not 100%.
Okay, no, but what I'm saying is that then you take the other part, like even here it says the 2.9%, and you try and see what is the 2.9%. Or is it,
Oh, yeah, actually it's supposed to be should have put it there.
yeah. So there is, again, and I would call that research, right? To see what that is, because I'm very surprised that this number is so many times in the figures.
Also just be that the person didn't pre-process and cut the adapters, and that's every time they
I know, but it's research. We don't know until Mpango or you or somebody
But I
else.
mean, you could start with a fast PC and just see at the bottom is the adapters of the
So maybe it's in there. So if you look down here, you're going to see some stuff on maybe adapters up over it there, you know. And so maybe if you add up these numbers over here, Tracy, like what you're saying, maybe if you add up this, it adds up to something close. I don't think it does in this example, but what I'm saying is that what you're saying, Tracy, these are all hypotheses that need testing. Okay, so what Mpanga is basically saying is, which hypotheses are we going to test?
And what
And
you also need is you need to look at the report and see what suspicious amounts you
yeah.
have, and that could really lead you to what hypothesis you should.
But so what this means is that in your lab, you're having a bioinformatician whose job is not just running pipelines, but it's also research and tool building, right? Because mostly when you have what do you call the job designation? Like a lab technologist, right? Who's building up who's filling the plates, who's doing the PCRs and things like that. Are they researching lab processes? Are they doing research as well to just see like why are my PCRs failing and all of those things like that? To some extent. And then they may be doing it using Excel and looking at like this week's which batches were failing. Maybe always the batches from that health facility were failing. Then we discovered that they're not being transported in time or something like that, right? So there is that kind of research, but bioinformatics research, like Panga and Tracy are talking about as well. What is this thing? What's the contaminant? What extra tools? Can we add a filter here? And then you guys are all in Colgen. Can you work on within Colgen? Okay, we added this extra filter. We found that there's this common contaminant. There's, or something like that, right? And then maybe, hopefully, the only thing is, once you do come up with a solution, hopefully to get it outside of one consortium and to like say, hey guys, the best practices for cholera, is this. You should do this, make a little document somewhere. Might not be an academic paper, but this is the problem that we have is very often like it's me who gets stuck with these questions, or maybe George or Ivan or John or whoever happens to be here in front, or Tracy or Nazar, okay? And the solution can't come from like planet-sized like knowledge bank that we need to either do research, okay? But it is a very interesting one that we're finding here. We need better, and I do think that like one of the tools, that one better set of tools that we need are flexible tools for making yes/no decisions on when you've got a batch. Because most of the automated pipelines, they just process all of the samples, and we need more flexible tools to then pull things out, examine them, and then divide into further research needed samples. These ones we can go ahead with samples, etc. Right?
No, Peter, now I remember. I think my question then was right. Going back to what you said, that for short reads, you can have reads that are marked, but they are for contaminants.
Yeah.
So,
they say even have a name for it, the contaminant of, yes.
Contaminant reads, like
Yeah.
a read that's coming from, any.
Can be phi X, can be anything.
Reference based, I mapped to, cholera reference. So the point that you made that for short reads, the chances that I can get a short read that's not a cholera read and it's mapping to my reference. So that's why I was thinking now that if I did the mapped ones, what are the chances that I can find a read from a contaminant that's other than Vibrio? And it's
In your de novo. Because
in my de novo, all
the ones that are mapped. Yes, it's possible because that so the thing is, how is Mpanga's scenario going to work? How would we get an assembly which has incorporated a contaminant? Guys, how would that happen? How would you get? Here is an assembly.
Yeah. So this
you do an assembly, right?
And
you get an assembled.
This assembly was reference based, right?
No, but okay, but we've let's call it. Let's first call this filtering. We've filtered out all the unmapped reads, okay? And now you're going to do an assembly of just the mapped reads. But
you say that because it's short, it could still
no. So the question that
let's assume I have a directory containing mapped reads or read maps.
And in this assembled config, Mpanga, you're saying that there's a contaminant in it, right?
We have a directory, the code mapped reads.
Yeah.
That's after obviously doing reference based. Yeah. Then I go to that directory of mapped reads.
Yes.
And I change now. I do de novo of the
Mm-hmm.
Yes. What are the chances that I can find? And then, okay, so when I do the de novo, I do the de novo of the mapped reads. Then I take that into, say, Kraken. And there are possibilities that I'll find on the list of the hits, and I'll get other things.
But hang on. Okay, firstly, you can't put assemblies into Kraken, okay? But the other thing is this possible? That you assembled, the reads that we used for this de novo assembly were only ones that mapped to the Vibrio cholerae reference, but a contaminant ended up in your assembly. So is it possible, and if we're going to answer this question, we have to always answer, is it possible, by a model of the world. So what I would then say is, how could it be possible? How could something like this happen? What could lead? Because remember, how is an assembly constructed, right? How is an assembly constructed? And why do we get those bandage graphs the way that we do, right? Because what we do is we find reads, we have a whole pile of reads, and then we group them. Modern assemblers, spades, all of those kind of things, they find the areas of overlap between reads, and then they find a path between this to they do a Eulerian walk. So they find a graph called a de Bruijn graph, and then they navigate this graph, okay? So can we get a contaminant in our de Bruijn graph? Can it get incorporated into the thing? So now we assume that, so firstly we filtered by only choosing things that map to Vibrio cholerae, okay? Leaving aside the filtering, if we didn't filter, could we get a contaminant in a config, and if so, how? No, let's assume let's leave the filtering off for now, just to say, let's look at the basic problem. Can we get a contaminant in a config when we are doing a de novo assembly, and if so, how does that happen? Okay, one at a time. I've got the. Oh, sorry, you think you can? You had some ideas. How?
Yeah, if you're doing it in a assembly, yeah, it's possible if the contaminant rates, if they are short rates, and then there's enough of them to actually generate a config at least.
No, but that can give you a separate config. But what we're talking about is a config that's hard, that's chimeric. Some of it is some of it is Vibrio cholerae, and some of it is something else. Can we get chimeric configs from short reads? And if so, how? Think about it, okay? Eric thinks that we can. What's your theory? So if our contaminant reads overlaps a bit with our Vibrio cholerae reads, okay? And then it gets sucked in, okay? So then, leaving out the mapping filtering step, yes, if we found something, because life has many commonalities, housekeeping genes that are shared between many different species, and things like that, okay? So then it's possible that this thing gets incorporated by its overlaps into the assembly. But is that possible once you've already used the Vibrio cholerae reference to map things, okay? And I think the chance becomes now much less, because what we need now is something that looks enough like Vibrio cholerae to map to Vibrio cholerae, and thereby be incorporated into the assembly, but it's not Vibrio cholerae. So if there was, we'd probably be talking about not a Morganella, that's quite different. We'd be talking about like another Vibrio, you know? You know? So the thing is that, like, in the clinical sample, I'm starting to think that it's unlikely. Okay, I haven't tested it, but yeah, George.
Yeah, so I agree with you, and indeed that would have to be cross contamination between samples. We did in lots of samples in the lab, and indeed, you're gonna learn from the other one, which people always fail to notice, has to do with the sequencing technology. So often you do one run, and then you do a wash. Often in a sequencer is usually remnants. So the way to sequence is to do one sequence, if you enter it, do one run, then sequence something else, okay? And then do another sequence. Because there can always be crosstalk, particularly with mice, between both products. So you're going to incorporate them. Yes. Exactly.
Yeah, but what George is saying, if you sequence cholera, then you increase the chance for sample to sample contamination.
Yes.
Because if you do another sample in between, you're more likely to have unmapped units and you can just chuck iron.
Well, no, I mean this, yeah.
The other one is leaving the marking. You have to be careful about what your mark Q is. So if you think there is potential crosstalk or leave a brand like two branch runs, I would be careful about what my mark Q is. My default position is 60. It's the degree of association. And the lower you mark Q, you're going to have things that are marked in the genome that are not necessarily very. It shouldn't be marked.
So this is, George has mentioned a really important thing, MAC-Q, okay? So we've spent a lot of time looking at Q, quality of the individual sequencing base, okay? Which is an estimate of like how sure we are that that base was really that in the sequence, okay? But MAP-Q is an estimate of, do we really believe when we are doing our mapping that this does map there? And it gives us a score MAP-Q, okay? Now, MAP-Q, there is no standard between software. So MAP-Q for BWA, if you get the same MAP-Q by Bowtie, you can't actually compare them to each other. They have some model of the scoring, okay? So you can do things like increase the MAP-Q, but the other thing that you can do is when BWA is mapping, you can it first looks for a partial match, which is called the seed. And then when it finds the partial match, it then tries to extend the match. So if you want to be more strict, you can increase the length of the seed that you need, which means that you could have false negatives where just a SNP or something like that, or some sequencing or something, a SNP. If you obviously you can think if you put the seed too long, the seed must be a perfect match, right? Okay. If you put the seed too long, then if there's a SNP in the middle of the seed, then it will falsely discard the match. But you must find the value. But some colleagues of mine working with mycobacteria, their filtering procedure is they put they said they want at least 100 base pairs of perfect match.
But can you choose an area where you know there's no variability?
What? No, this is for all over the genome. We can't choose by anywhere in the genome. It's a minus K parameter for BWA. For every read, they said we must give at least 100 bases of perfect match. Okay, but now how long is your read? Okay, depending on your technology. So the next seek is 150, right? These days, 150 base reads. Next seek. You can do 250 on the next seek. Okay. So if you say you need at least 150.
So George, that's very interesting.
Yeah.
Just a little bit of light on what MapQ is and what the values mean. Because I've seen like in this one it says MapQ is should it be 100?
So often MapQ 0 means things like it's mapped in 2 different locations. It's multi-mapped.
Yes. So you have no confidence that. So what is happening is that read is mapped into multiple locations of the genome, and you'll always see that, particularly if you have repetitive regions. So if I have a read that's 50 base pair and it's within an repeat region, you maybe have multiple bits of contamination. My MapQ for that read will be 0. All it's saying is that this read is mapped into so many places.
When you put it at
So 60 means a perfect match.
The same concept. It's called because each other uses a different system as a yes. So after you can track, yeah.
Well, just remember the RNA you also very obviously you will have differential expressions so have multiple experiments, so it depends on the so
no, just trying to understand what MapQ is.
So, but it differs radically between different software, right? So, Top Hat, which is not used anymore, but it was an older RNA-seq mapper, would use 0, 1, 3, and 255. Okay. So the MapQ is MapQ for the tool that you're talking about. Okay. So apparently, I don't know if this is still up to date, but they haven't updated BWA in ages. But bow tie goes 0 to 42, BWA goes 0 to 37. George, isn't 20? But who is doing MapQ 60? Is that BWA?
BWA used to do.
It used to do 60, and it can even but I've seen a lot of MapQ 20 things like that. So interpreting the cutoff for MapQ is super hard because they could also change in the tool. That's why a lot of pipelines don't. So what you do know is when it's low, like 0, 1, 2, 3, 4, whatever, then that's multi-mapped and you're going to throw it away generally.
Yeah, so the other thing I would like to mention often is that if we're talking about contamination, I'll also be quite careful to look at the lab itself. You know, is it accredited? Do you have GCP?
Yeah.
Because those makes a lot of importance. So, for example, if you send me like loads of reads or a big project, that we've done sequencing of Cholera, there are a couple of things I want to check about the quality of the setup of the lab and the people working in that lab. Because that's the only way to guarantee quality in a microbiology lab. Whereas that if you got a lab and today you just think, I'm just going to take cholera and start sequencing, and I don't know whether everyone in the lab is accredited, I'm going to run into a lot of these issues. And therefore, I have very little confidence to begin with those data, to be honest. I may sound a bit subjective, but I'll be quite careful about it. So there are all those processes that you've got to ensure so that you know that the people who are working with the data as mentioned are actually qualified, actually, the sterility in the lab, the flow, is it, the
Unidirectional flow.
How are samples moving from one area, who is handling those samples, and the entire laboratory protocol, because then you get to avoid a lot of these issues. If you got issues at the lab from the beginning, the data will always be in trouble. And we can do what mine. We can do all this, but sometimes it's just running around in the desert.
But and I mean the lab issues, we've seen them in all sorts of ways. I mean, I was a reviewer on a paper that claimed that it had found a Omicron in Zimbabwe from before Omicron was known. Okay.
So this the science paper that was
No, that was another rubbish paper. But you mean the one from Drosden and Co.
Yeah.
And that was another piece of crap. But this one I rejected. I recommended just straight rejection to the paper because there were so many issues. But the thing is this, that when the sample that they looked at, and I looked at the sample, and there was bimodal distribution of allelic frequencies. So you could see that some variants were at 20% and some were at like 80%, and it looked very much like contamination. Okay. But then I contacted the lab that did the sequencing, and I asked them, look, this sample, we know it was deposited in the database at this time, but when did you guys actually sequence the sample? And I found it was at a time, so they'd collected the Zimbabwe samples back in August, but at the time that they did the sequencing, it was when they were doing a lot of Omicron sequencing. So it was not surprising that there could be a little bit of DNA floating around the lab and contaminating samples. These are the kind of things. And then, as you say, the crosstalk between sequencing runs is actually very interesting work that somebody's done. They found in other sequencing projects, in Antarctic metagenomic samples, they found SARS-CoV-2 from early 2020. And if you go and look what happened there was not SARS-CoV-2 in Antarctica in early 2020, but when they were sequencing the samples, they were sequencing them, and probably a high-capacity machine, the next lane in the sequencer, had SARS-CoV-2 samples being sequenced. So a few reads did what they call index hopping, jumped across into the metagenomic samples, and then you can see it's some way of getting early SARS-CoV-2 samples is from doing that, But anyway, so MapQ, so many things, but I don't know. I mean, this is why I like experiments, community, all of those kind of things. Okay. Now, I want to shift gears, and I want to look at at what I sent on the WhatsApp yesterday for literature review, okay? Because I want to talk nanopore. Yes.
I have some doubts about yesterday regarding phylogeny.
Yes.
What is the best approach to contextualize our samples? For example, when I work with influenza and I'm studying a certain period, for example, I want to do a phylogeny tree, I download all the samples from that period, I build a local database, then I blast my samples against them to find which one correlates best with my samples.
And then you choose some similar ones.
Sure.
It's a problem. Yeah, I don't have a great solution. And in fact, it's something I was asking Ivan and Mpanga in the last 2 weeks. How do you choose a good contextual data set? So the approaches that I've seen have been try and find representatives. So if your organization or if your organism has known clades, try and find some representatives of the known clades you know. Try and get a geographic distribution. One of the things is that you have to, when you're looking at the genomes in the databases, you have to choose ones that have good quality statistics. Like with Vibrio cholerae, it's good if you can find ones which are finished with 2 chromosomes instead of 2 contigs instead of many. But yeah, I don't have a. It's work, and yeah, I don't know. Other people, how do you choose your other samples to include in your phylogeny?
Is this for viruses?
For any project,
Geographical location.
geographic spread.
I would just use sort of what is known, sort of the metadata. So, for example, if I was at the Kenyan coast and there was a nice or big cholera outbreak, but anyways, that's not nice. But I would think about where this sometimes like it will happen. So I would definitely choose inner data from the Arabian Peninsula. We've got a lot of movement. I would definitely choose data from Malawi because proximity geographically. I would also choose inner data as from South Africa or anywhere, and then I would have this huge Southeast Asia. And initially you can run sort of a small analysis, and you start to see something interesting. Maybe now ask is this real? Then I would add more metadata. For viruses, there are 2 approaches. One that might be quite straightforward is to use the auger pipeline that's written by the Next-Gen team. Within it is an algorithm like Peter mentioned that checks for proximity so that you get your genomes. And then what it's going to do is that it's going to cross through this or your data set. It's going to look for representative genomes that are most similar to your data, and you can use those as your contextual method.
But for science,
yeah, that's scope too. But you can do that even for others now. It's possible.
If you can get access to the database, yeah.
Yes. The other one is to do now phylogenetic placement, where I would go score through my data set. I would build a very big tree of everything. I'll take my samples and I will place them within the phylogeny. There is a nice algorithm of superfast that can allow you to do placement. Then I'll take those clades where my data came in, and again I can decide on how big or how large it is. I'll take those as my contextual metadata.
My problems honestly often start upstream of this. That searching the databases, they're not well organized, right? So that you can use it's better with NCBI virus these days with viruses, but for bacterial species to actually find good ones to match with, it's a lot of work of searching things. The metadata is not well populated and all of those kind of things, okay? So well curated reference, kind of contextual data sets are gold to me. The other problem is that then you'll find your bacterial genome, but it's got 200 contigs, okay? So now, when you are building a phylogeny, you have to start with the multiple sequence alignment, okay? And now you need to try and scaffold these 200 contigs into your. It gets really complicated and difficult, So maybe you go back to the actual sequencing reads from that. But to me, I must admit, it's a bit of a. It's like a big task for every project, and it's a bit of an open question. I agree with the approaches, geography, clade, all of those kind of things. But I get very frustrated when I read these papers that show their phylogeny, but don't actually give the identifiers for which that you can only then from their data release you can only get their data, but they don't tell you which samples were in their contextual data, Or maybe they tell them, but they don't give IDs, which are the database IDs. They give their sample IDs from something else. So, yeah, I don't have a great solution. I find it's one of the biggest pieces of work for most projects is to actually put things in context. Somebody will give me money to build a better system for that.
Your paper, somebody releases this wonderful data set that they've been working on for the last 5 years.
Yeah, if you're lucky, if you find that. The one I find that the wonderful data sets don't get released. They get kept in somebody's private lab and never, like, I mean, one of the things that frustrates me a lot is like when I read these papers from like ITM in Belgium, where they look at like the diversity in all of the mycobacteria, but I know that they've got an in-house amazing collection that they've been collecting for years and things like that, which they've never shared, you know? But I don't have a great solution, and let's call it an open problem. And I do it project by project. And one of the things that I would like Phage to work on, but we don't really have the people, the money, the resources, or things like that, is better reference data collections. And then when it comes to influenza, I don't even have access to EpiFlu, and I don't even know how to get access because your emails don't get answered. If you're not friends with somebody in DISA, then unless you're at a WHO coordinating center or something like that, okay? Then with the GISA database, you get the access that they decide to give you. So now I used to be able to download the whole of GISA, which I used for some of my research to do. They took that away from me. I can't do it anymore. No explanation given. So I'm very frustrated with the GISA database. I don't know. George, have you downloaded the whole of GISA recently?
Yes.
I can't anymore. They took that option away from my account.
We just got to
No, but then if you get if you're lucky.
an opinion piece, and I think I'll lose mine.
No, because the thing is that like I could send them another, because I'm not working on it at the moment, so it's not urgent. But like I think it's totally wrong that they took away that access without any explanation and without any I did nothing. It's just one day I logged back into the database and then it's gone. So and you know there's this saying that data is the new gold, right? And so people so when people are building empires around data, it annoys me, you know. But yeah, so I don't have a great solution for that. The techniques, yes, but I agree with all the technique suggestions, but how to actually execute those techniques, it's not the easiest thing in the world. Any other questions before we talk about literature? Yes.
So it's still around, it's sort of reference as well. So for Archaides lyrics, diphtheria sequences, yeah, it did work. I got the assembly, but it didn't run the sleepy core.
It didn't?
No, yeah, it stopped. So I checked and I found that I think it's something with the reference. I don't know.
Well, I'd like to look at that particular error, because that might be. I want to see if this is a technical fault or